we're going to make a start on the section on the solar system, okay? And what we're going to do by starting off, obviously the solar system is the sun, okay, as you probably know, with all the various planets orbiting around it, okay? There's a bit of what I would call kind of geography, all right, knowing the various bits of rock that go round and where they are. So you need to know the sequence of the planets, okay? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, okay? There's various silly ways of remembering it, or at least when Pluto was involved it was. My very eager mother just served up 9 pizzas. Is quite a good one. But a really good one, which I can use because I didn't invent it. A year 9 student, years and years ago, made this up, and it's much, much better than anything I've dreamt up. My very easy method just speeds up naming planets. My very easy method just speeds up naming planets. So that's, I think, the best one to use. But you need to know the order. They'll ask you things like which planet's close to the sun, etc., etc. You need to know the order of the planets. And basically the idea that we have basically 2 groups of planets. We have the planets here, which are small, sort of rocky planets. Mercury, Venus, Earth and Mars are mostly rock with a little scrap of atmosphere around the outside. Okay. Planets out here are, well, in the syllabus anyway, referred to as the gas giant planets. Jupiter, Saturn, Uranus, Neptune. Okay. There is a tiny planet on the outside there. Okay. Beyond the orbit of Neptune, astronomers looked for many years to find another planet. We'll look a bit more about the discovery of these planets a bit later. But astronomers looked for many years to find a planet beyond Uranus, okay, and came across Neptune. They looked for a planet beyond Neptune and found Pluto. But we now know that Pluto is part of a whole load of other planets, some of which are bigger than Pluto. All right, there's a whole bunch of things out here called the Kuiper Belt. All right. We now know the edge of the solar system is marked by the Kuiper Belt. All right. It contains a whole bunch of quite small planets, of which one is Pluto. All right. Pluto is just an amazing discovery. As I say, we'll look at the discoveries a bit later on. But there's no way Pluto should have been discovered in 1930. With 1930s technology, how on earth could you see Pluto at that distance? And its discoverer, Clyde Tombaugh, did an incredible job and spent many years of absolutely mind-numbingly boring work to discover Pluto. All right. What should really have happened is Neptune should have been discovered in the 19th century. Nothing should have happened then until we started to discover the Kuiper Belt. All right. So it's hats off to Clyde Tombaugh, who managed to discover Pluto, which had a brief period from 1930 to 2005 or 6, when it was thought to be the only planet at that distance. We now know it is just part of the Kuiper Belt. All right. So for that reason, these things are referred to as planets. Okay. Pluto is now no longer referred to as a planet. It's referred to as a dwarf planet. Okay. And you need to know the reasons why. As I say, in 2005 or 2006, the International Astronomical Union took the decision. If you want to be a planet, and this is the result of their decision, if you want to be a planet, then you have to basically tick 2 boxes. Okay? You have to be large enough to be spherical. Okay? That's why the asteroids which live here, you with me? Most of the asteroids are not planets of any kind. All right? Because they're not large enough to have a spherical shape. Okay? So that's the first thing you have to tick. The second thing is it's important that you have cleared your orbit. In other words, of other objects. So, Jupiter is a good example. At that distance from the Sun, what else orbits the Sun at that distance? Not a lot, really. All right. If there were any bits of rock orbiting at that distance, by now, Jupiter would have hoovered them up. All right. So at that distance, Jupiter is pretty much the only thing going round, and for that reason, Jupiter is a planet. Okay. And this is where Pluto, obviously, is a tick and a cross. because Pluto is large enough, as we now know from the New Horizons photographs, it really is spherical, and it definitely hasn't, although from 1930 to 2005 we thought it had, but we now know in the 21st century that it's not cleared its orbit. There are many objects out here, okay? And that's why Pluto is referred to as a dwarf planet, all right? It's large enough to be spherical, but it's not cleared its orbit, okay? And as I say, this is something you need to know. What is the definition of a planet as opposed to the definition of a dwarf planet, okay? So there's lots of dwarf planets out here. There's a few in the Asteroid Belt. And the ones that you're used to, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, are obviously proper planets. Okay, I haven't drawn my diagram to scale in any way, but there is a big gap here. There's quite a big gap between Mars and Jupiter. It looks as though a planet clearly tried to form there, but the effect of Jupiter and Mars's gravity together will have pulled it apart and left it as a bunch of rocks called the Asteroid Belt. Okay, not to be confused with the Kuiper Belt. All right, Kuiper Belt actually comes inside the orbit of Neptune. Neptune is on the edge of the Kuiper Belt, okay? And the thing I can't get across here, because I've messed this up really, is the discovery of Uranus. Sorry, start again. The discovery of Uranus basically doubled the size of the solar system, okay? The naked eye planets go out as far as Saturn. You might think I've never seen them all, but they're all possible to see with the naked eye, all right? So with the naked eye, you can see as far out as Saturn. Okay, Mercury is probably the hardest because it's so close to the Sun. Venus has been quite big in the dawn sky recently. Can be very bright. Can be the brightest thing in the sky after the Moon. You need to think about why that is. Mars you can see quite clearly. Jupiter and Saturn, I'm sure you have seen them, perhaps not realise what they are. But in the evening when it gets dark, before the stars come out, so when the sky is dark blue, if you see just the odd star here and there, people say, oh, look, here come the first stars. It generally isn't. The planets, or the naked eye planets, are all substantially brighter than the nearest star, okay? So in the early evening when you can just see a few, dots, you're almost certainly looking at a planet, all right? Most likely to be Jupiter, Saturn or Venus, okay? Uranus, its discovery, basically doubled the size of the solar system, all right? So I haven't got room on the board for this, but basically, if you can imagine however far you put Saturn, Uranus, there's the camera now, Uranus will double the size of the solar system. So Uranus and Neptune are often referred to as the outer solar system, okay? Because in terms of scale, there is an enormous gap. There's a gap almost as big as the whole solar system between Saturn and Uranus, okay? As I say, we'll come back to these. We'll look in more detail at their discoveries, but that's the basic structure of the solar system, all right? And there are some jargon words: gas giant, rocky, planet, dwarf planet, asteroid. If you look in your spec, those are words that you need to know exactly what they mean, okay? There are some other funny things going around, like centaurs and PHOs and stuff, which we'll do a bit later, okay? Is everybody happy so far? Right. Now, if you have a look at your sheet, which I've given you, which is available on PDF via email, on there is quite an important couple of diagrams, all right? What those diagrams are to do with is if we're stood here on the Earth and we want to look out at the other planets, all right, then where should we look, when's the best time to look, etc., are explained by those two diagrams, all right? So if you want to look out with a telescope and you want to do some observations of Mercury or some observations of Saturn, then how would you go about it, all right? Now, the first thing you have to do is to divide the planets out there into two groups. And again, these are words you need to know. There are inferior planets and there are superior planets, all right? It's very simple. Inferior planets are closer to the Sun than we are, and superior planets are further away. So the two inferior planets would be? Mercury and Venus. That's it, all right? It's going to be Venus and Mercury, and all the rest are superior. Okay. If you lived on Venus, your only inferior planet would be? Mercury. Be Mercury, wouldn't it? All right. So it's a simple idea. If you're closer to the Sun than we are, you're inferior. If you're further away, you are superior. Okay. But it makes a big difference in terms of, as I said, trying to look at them, trying to observe them. Okay. Let's start off with the superior planets. So on your little sheet that you've got, that's the right-hand diagram. Okay. If the exam said to you, well, how would you go about observing Mercury? How would you go about observing Saturn? They'd expect very different answers, because Mercury is an inferior, whereas Saturn, for example, is a superior planet. Okay. Let's see how it works. You've got the diagram there, so you can just scribble over it. You don't need to copy it down particularly. Okay. So let's take the Earth. Let's not take the Earth. Let's take the Sun. Let's have the Earth going around it. Okay. Now, we don't want to move both planets at the same time because we'll get very confused. So let's keep the Earth still and let's have the planet going round. So this is any superior planet. What we're about to talk about now applies to Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, whatever. Okay? Here's a superior planet. It could be there, it could be here. Okay. Now, let's take this one down the bottom, for example. What would you notice if you tried to look at the superior planet when it was here? Imagine you are on the... So put yourself in this diagram. Imagine you are here on the planet Earth. You've got your telescope. You want to look at the planet and it happens to be here. What would you notice when you started to look at it?
You'd see the sun.
You'd be looking pretty much straight at the sun, wouldn't you? All right? Probably not ideal. I think you can probably guess. This is not an ideal position for observing the planet. Okay? If you are looking out into the sky... And, well, if you see two things very close to each other or lined up in the sky, that has a name. It's called conjunction. All right? Now, conjunction isn't just a term that applies to the planets. All right? Any two things in the sky can go into conjunction. And, I mean, look at the word, conjunction. It means they go next to each other. All right? We've been looking in the history of astronomy about people like Copernicus and Kepler getting very bothered about the fact they couldn't predict the exact positions of the planets to a few degrees. And you think, well, who cares? It's mainly because they're trying to predict conjunctions. Copernicus, Kepler, people like that earned their money by doing things like horoscopes. People would come and say, what should I do next month? Or should I do this? Or should I do that? And they would need to look at where the planets were going to be in a few months' time. And in particular, conjunctions. In astrology, Mars and Jupiter are important things, but Mars and Jupiter lining up with each other is really significant. So although they're the greatest astronomers of whatever, they were actually at it for astrological reasons, and they needed to predict conjunction. Now, if you can imagine, if you're trying to predict a conjunction, but actually your position of Mars is a little bit out, and your position of Jupiter is a little bit out, you can look like a right wally, because you predict a conjunction, there's like serious daylight between the two, all right? Conjunctions are possibly the hardest thing to predict because you've not got to get one, you've got to get two positions of planets exactly right. Okay? So conjunction basically means two things lining up in the sky. Okay? However, there is an exception. So you could have, for example, a conjunction of Mars and Jupiter. What does that mean? It means Mars and Jupiter are right on top of each other in the sky. Okay. At the start of the course, we looked at the account in the Bible of the Star of Bethlehem. Yeah. And many people believe, some people don't believe, but many people believe the Star of Bethlehem is actually a conjunction of Mars and Jupiter, which would have happened at around that time and would have produced an exceptionally bright. I mean, in those days, everything was a star. Think about the date. Anything in the star was a star. All right, but they would have produced an extra bright star. The brightness of Mars and Jupiter, for example, would produce a huge amount of brightness. Okay, and it's just a conjunction. The word almost says exactly what it means. Now, there is an exception, which is when you line up with the sun. All right, when you line up with the sun, it's just called a conjunction. So, for example, if Jupiter lines up with the sun in the sky, you would simply say Jupiter is in conjunction. You lose the with the sun bit. All right? So conjunction, how many objects involved in a conjunction? Obviously two. So, for example, conjunction of Mars and Jupiter, except if one of the bodies is the sun, you tend to leave it out. So this position down here, let's suppose the planet is Saturn, let's say. If Saturn was here relative to the Earth, then you would simply say, as it shows you on the diagram, that Saturn is in conjunction, full stop. And you wouldn't say with the sun. So in the exam, if they say Saturn is in conjunction, And you think in conjunction of Saturn with, I don't get it, it's the Sun, all right? If one of the two bodies in a conjunction is the Sun, you tend just to say conjunction, all right? So can I convince you this point here will be called conjunction? Because where would you look in the sky to see it? Imagine this is your line of sight looking out from the Earth. You can just see it in line with the Sun, okay? Good for observation, bad for observation. I think we've convinced ourselves already. Not good, all right? So if you were asked about when's the best time to observe a planet, if it's a superior planet, conjunction is very bad. Two reasons. Two reasons why observing Saturn at conjunction is a bad idea. Why would that be? Yeah, you'll be looking basically into the daytime sky at the Sun. And obviously it's very hard to see anything apart from the Sun. What's the other reason? Yeah, could you get it further away from the Earth? No. If you look at the orbit of the planet, that's as far away as you can get, all right? And the other thing is it's behind the Sun. I mean, it might not be lined up exactly, but it's basically behind the Sun. Now, let's compare that with this position up here, all right? This is obviously much better, because where would you look? You'd look obviously there to see the planet. So this position is obviously very good for observation. We said down here it's no good because you're looking at the Sun. Well, let's extend that thought train. If you don't want it near the Sun, let's take the superior planet away from the Sun. In fact, let's take it as far away from the Sun as possible. Can you think of a better position in the orbit? And there really isn't one, is there? All right? There really isn't a better place for it to be. So this is very much the best position that you can find it in. Okay? Now, where would you look in the sky? Let's suppose Saturn was here, I've learnt from my astronomy lesson. I'll go outside tonight and think, right, I'm going to see Saturn. Whereabouts would I look then if I know it's up here?
The opposite direction to the Sun.
That's it. Can you see the point about this is 180 degrees between the planet and the Sun. So it's 180 degrees. What would it be doing when the Sun sets?
Rising.
Yeah. Can you imagine? As the Sun sets into the west, as the Sun sets into, here's the Sun. As the Sun sets into the west, the planet will be just rising. What will it do at midnight? Yeah, be at its highest point, won't it? All right. So this is absolutely perfect because the planet rises at sunset. It gets to its highest point absolutely in the middle of the night. All right. And then obviously sets again at sunrise. Okay. So this is the very best position. It takes its name from what we just said. Basically, this is called opposition. All right. If you buy an astronomy magazine and it's got like some data about what's happening in the future, it may say, big news, next month Mars comes to opposition. And what it means is Mars is literally opposite the Sun in the sky. All right. There's two reasons why that's good. One is because it's opposite the Sun. So you're trying to observe it, and where's the Sun? It's on the other side of the Earth. Are you with me? The Sun, the planet, reaches its highest point at midnight. The Sun is as far away as you could possibly get it. What's the other bonus of having it here rather than here?
It's closest.
Yeah, it's closest. All right. Particularly Mars gets very close at opposition, and you know all the really good pictures of Mars that you see are generally taken around opposition. Okay. So two words you need to know. They're on the diagram. Conjunction. Full stop. Sounds a bit odd. Conjunction. Well, what with? Conjunction means with the Sun. Very bad idea for observation. Start again. Opposition means exactly the opposite of that. The Sun is 180 degrees from the planet, and that means it's just perfect for observation because it rises and reaches its highest point absolutely in the middle of the night. Okay? Is everybody happy with those two words and how it fits on the diagram? Okay? Right, let's go and have a look then. We've done superior planets. So what I've drawn here would be true for Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, Kuiper Belt, whatever. Okay? Let's have a look at the inferior planets, and that's the left-hand diagram. Okay? Here are the inferior planets. Put the Sun in the middle. Here's the planet going round, but this time the Earth's orbit is the bigger one. The easiest way is to keep the Earth still, so keep the Earth still at the bottom. And let's imagine the inferior planet, could be Mercury, could be Venus, Let's imagine it at various points on its orbit. Okay. Now, if this is a clock face, 12, 3, 6, 9, where do I need to put the planet for conjunction? Just like a superior planet could still be at conjunction, or 6. All right. Inferior planets have two kinds of conjunction. All right. This would be conjunction, because where would you look in the sky to see it? At the sun. All right. And this would be conjunction as well, because where would you look in the sky to see it? Towards the sun. Okay. Rather confusingly, and I think this bit is not actually in the syllabus, this one is called the inferior conjunction, and this one is called the superior conjunction, which is a bit confusing really, because we're talking about an inferior planet. So you need to know that those 2 points are called conjunction. The fact that astronomers refer to them as the inferior and the superior conjunction, that bit isn't in your syllabus. You can just call them conjunctions, all right? So things I think you can see are a bit different for inferior planets, all right? They don't have conjunction, they have two. They have two possible conjunctions. In terms of observing the planet, would that be a good time? No. Conjunction and opposite and observation. Useful thing in your mind. Conjunction and observing it are pretty much always not going to go well together. All right? Again, you'd be looking straight at the sun, wouldn't you? Okay. There is, however, one exception. There is one exception with the inferior conjunction, which we'll come back to later. Now, to observe a planet, you want it as far away from the sun as possible. The problem with the inferior planet is they don't get very far from the sun. By definition, they are closer to the sun than the Earth. So, this is a really bad place. Okay? What about, why can't it go to opposition? They're always closer to the sun than we are. To get to opposition, you'd need to be there, wouldn't you? So can I convince you opposition is only something the superior planets can do? You can't do opposition if you're an inferior planet, all right? Getting 180 degrees from the sun is not an option when you're always closer to the sun than the Earth, okay? Now, follow that thought train though. We can't get 180 degrees from the sun, but we just want to get away from the sun. A good idea would be something like that, wouldn't it? Yeah? Would be to go to 3 o'clock and 9 o'clock. All right? If the sun is here and the planet's going around this circle, where's the best place? Well, there aren't any good places, but the best would be right over here, where it's as far from the sun as we can get. Okay? However, that's not quite the case, I'm afraid. On the clock face, 3 o'clock and 9 o'clock would be the best places to observe them if the Earth was an infinite distance away. All right? But these planets are at a decent fraction of the Earth's distance from the sun. And so if you draw it carefully, which I haven't done actually, a bit better on your one, I think, on your diagram on your sheet. Okay? Can I convince you that this angle is the important thing? You see? If you've got Venus or Mercury to this position, and you think, well, this is as good as it's going to get for observation, you'd go out in the sky and say, right, the sun is there, the planet's there, there's this much angle. It's never going to be 180 degrees, but it's the biggest it's going to be. Now, I've drawn it as carefully as I can. Can you see that that's not quite right, is it? Look at the clock face. We're on the right track with 3 o'clock. We want to get this angle as big as we can, don't we? Is 3 o'clock the biggest value of that angle? It's not, is it? You could go to here, about 4 o'clock. 4 o'clock, it's ever so slightly bigger. Okay? Can I convince you that this difference, imagine I move the Earth away. Imagine I move the Earth much further away. Can you see this difference is going to get smaller and smaller and smaller, isn't it? All right? And if the Earth was an infinite distance away, then it would be at 3 o'clock. But it's not. Around about 4 o'clock, not 3, you reach this position here, which is the position of it's called maximum elongation. This angle in here is called the angle of elongation. All right? And the maximum value occurs at about 4 o'clock on the orbit, where it's called maximum elongation. So as I said, if you buy an astronomy magazine, it'll say to you, big news next month, Mars' opposition, excellent news for observing, and Venus is reaching maximum elongation. Again, that's your best chance to see it. Okay? So if I said to you, where's the best position to observe a superior planet, you would say opposition. All right? If I said to you, where's the best position to observe an inferior planet, you would say maximum elongation. Okay? This angle can get quite big for Venus, which means you either see Venus, if you can imagine, because you need to use the limb of the Earth, don't you, to kind of mask the sun. So that's why you sometimes see Venus dropping into the sunset. As the sun's gone down and it's just left a red sky behind, you can sometimes see a bright dot going down with it, and that's Venus. On the other side, I can draw this again on the other side. You can probably imagine. Is it on your diagram? Yes, it is. On the other side, then you would actually have this Venus. This is what happened a few weeks ago. Venus was rising into the dawn sky. So before the sun had risen, Venus was hopping over the horizon and spending about half an hour in the sky before the sun came up. Okay? And that's why Venus is often referred to as the morning or the evening star, because it's often seen rising in the dawn or setting in the dusk with the sun. Okay? I can't remember what this angle is for Venus. It's something quite reasonable. All right? For Mercury, can you see the problem? For Mercury, it's going to be even smaller. I think many astronomers go their whole lives never seeing Mercury. It's really difficult. Even at maximum elongation, it's very close to the sun. Very difficult to line telescopes up and things like that. You've got to be very careful because obviously the sun is nearby. And it is really a very difficult thing to see because at maximum elongation, this angle of elongation is still quite small. Okay? And of course the brightness of the sun kind of extends over quite a big area. Okay? What's the angle of elongation at conjunction? 0, isn't it? Can you imagine what's that angle going to do at conjunction? Yeah? It's going to close up to 0, isn't it? All right. Now there is one tiny exception we've missed out, which is at inferior conjunction. Every now and then it is possible to see the planet at inferior conjunction. Venus did this a few years ago. How might you be able to see? So imagine you're looking out into the sky. There's the sun. All right. Here's Venus at inferior conjunction. Okay. Next time it comes to inferior conjunction, where might it be? It might be there. Or very occasionally, because the sun isn't that big, you can sometimes get Venus to come to maximum elongation. Yeah. Very occasionally at inferior conjunction for an inferior planet. Very occasionally the planet will actually cross the disk of the sun. Okay. Now the way I've drawn it looks fairly inevitable, but as you probably know, the thumb is at the the sun is actually, is it your thumb at arm's length or something? It's a really small angle in the sky. Okay. Think how long and thin these diagrams are really. What are the chances of Venus coming to inferior conjunction and actually lining up with the disk of the sun? They're really, really small. Okay. This has a special name and it's referred to as a transit. Okay. Very, very rarely at inferior conjunction, 99.9 times out of 100, you can't see it at inferior conjunction. You see the sun, Venus is like just below it or just above it. Okay. I've drawn the sun's disk enormous to show the point, but generally this is very, very rare indeed. Okay. But occasionally you can see it as a transit. Okay. Transits are very rare. They're very interesting. They tend to come in patterns. I'll leave you to think about why over half term. They tend to come in gaps of about 150 years. And then they come in, well, Venus anyway, comes in about 180-year gaps. And then they come in pairs about 8 years apart. Okay. 2001, I think for Venus it was about 2001. All right. And then again in 2009. 2009 one was an early morning. It was just leaving transit as the sun rose in the UK. I can remember getting up thinking, if the weather's good, I'll get the whole family out of bed, because the next one, you with me, isn't going to happen for another 150 years. So if you miss the 2009, then you've probably had it really, because it isn't going to happen again for another 150 odd years. Okay.